State the real stakes in plain terms. A glassblower only has this one curved outline, spun around, and you're being asked how much the finished vase would hold before a single drop is poured in just from that curve. Keep that vase parked, we will come back and pour a real number into it. Direct question held for a beat. Take one wafer-thin horizontal slice out of that vase. Once it's spun into 3D, what shape is that one slice? Name the idea before any symbol. Slice the vase into thin coin-shaped discs. Add up every disc's ordinary cylinder volume, and that running total is your first estimate of how much the whole vase holds. Watch the blocky stack melt into the true curve as the slices get thinner. That's exactly what the integral sign means here. Then pay off the glassblower's question directly. For this vase, the exact answer is 8 pi cubic units, no jug required. Unpark that vase time to pour a real number into it. The reminder: to integrate, add 1 to the power, then divide by the new power. Run the numbers. Y squared over 2 from 0 to 4 comes to 8, so this vase holds exactly 8 pi cubic units. Into the shelf, volume of revolution about the y-axis. The rule in one line: whichever axis you're spinning around is the axis you slice along, and the radius is always the other variable. So rearrange the curve's equation for that variable before you set up the integral. Into the shelf 2, volume of revolution about the x-axis. Look from directly above the rim. This vase was only spun most of the way round, not the full circle. Before I tell you, what does that do to the volume? The fix is simple. Whatever slice of the full circle you actually spun through, take that same fraction of the full volume. Half a turn, half the volume. A sixth of a turn, a sixth of the volume. Into the shelf. Scale by the angle over 360 for a partial turn. The region bounded by the curve y equals x2, the x minus axis, and the straight lines x equals 1 and x equals 2 is rotated through 360 degrees about the x minus axis. Find the volume of the solid generated, giving your answer in terms of pi. Spinning about the x-axis means stacking disks along the x-axis. Radius equal to y, exactly the left-hand panel from before. Square the curve, y squared becomes x to the 4th. Integrate, pi times x to the 5th over 5 between x equals 1 and x equals 2. At x equals 2, that gives 32 fifths. At x equals 1, it gives 1/5. Subtract 31 fifths, so v is 31 pi over 5. V equals 31 pi over 5 cubic units, about 6.2 pi, roughly 19.48 cubic units. That comes from pi times the integral of x to the 4th, from 1 to 2, which gives pi times x to the 5th over 5, evaluated between 1 and 2. The region in the first quadrant bounded by the curve y equals x2 plus 1, the y minus axis, And the straight lines y equals 1 and y equals 5 is rotated through 180 degrees about the y minus axis. Find the volume of the solid generated, giving your answer in terms of pi. Spin about the y-axis this time, so stack the disks along the y-axis. Exactly the right-hand panel and the vase again, but first rearrange. Y equals x squared plus 1 gives x squared equals y minus 1. Find the y limits from the region itself, not the old x limits. Y equals 1 to y equals 5. The full 360-degree volume is pi times the integral of y minus 1 from 1 to 5. That comes to 8 pi for a full turn. But only half a turn is asked for, so have it, 4 pi cubic units. V equals 4 pi cubic units. The full 360-degree revolution gives 8 pi, from pi times the integral of y minus 1, from 1 to 5, using x squared equals y minus 1 rearranged from the curve, and y limits of 1 to 5. Since only a 180-degree revolution is asked for, have it, 4 pi cubic units. Back to the glassblower's vase. Spun around the y-axis, it holds exactly 8 pi cubic units, no jug required, and that came straight from slicing it into disks and integrating. Whenever a region bounded by a curve, a line, and an axis is spun to make a solid. First decide which axis it's spun about. That axis is the one you slice and integrate along. X-axis spin needs y2 dx. Y-axis spin needs x2 die. If the curve isn't already written with the other variable as the subject, rearrange it first, like turning y equals x2 plus 1 into x2 equals y1, and always refine the limits in that same variable from the region, not by reusing the original x limits out of habit. Compute the full 360-degree volume from the integral in terms of pi and only t, h, e, and check whether the question actually asked for a full turn or just a fraction of 180 degrees, 90 degrees, 60 degrees, and so on. If it's a fraction, multiply by angle/360 as the very last step, and never bolt on an extra area or volume term that isn't part of the integral itself.